Hello everyone, welcome to this video looking at the topic discriminant. So what is discriminant? I hope you know the quadratic formula minus b plus or minus square root of b square minus 4ac divided by 2a. So in this formula, the part which comes under the square root is called as a discriminant. The discriminant tells us how many solutions the given quadratic will have. There are three options for the outcome of the discriminant. The first one is b square minus 4ac is greater than 0. So if b square minus 4ac is greater than 0, then the quadratic crosses the x-axis twice. And there are two real distinct roots. Okay. Next, b square minus 4ac is 0. So in this case, the quadratic touches the x-axis once, so there is only one real repeated roots. And the third case is b square minus 4ac is less than 0. In that case, the quadratic will not cross the x-axis, so there will be no real roots. So no real roots. Actually, the solution is nothing but the quadratic and the line intersecting point. Okay, in the first case, it intersects at two places, so it will have two real distinct roots. In the second case, b square minus 4ac, it actually touches the line. The quadratic touches the line, so it acts as a tangent. The line acts as a tangent. So in the third case, the quadratic will not cross the axis, will not cross the line. So no real root. Now look at this quadratic and the line. Here we can see the quadratic crosses the x-axis twice. So the point of intersections are the roots. So in this case, a b squared minus 4ac is greater than 0. So in this case, the quadratic touches the line. So b is a tangent. So in this case, it has one real and repeated root. And this is the third case, b square minus 4ac is less than 0. That is, the quadratic will not cross the x-axis or the line. So there will be no real roots. While solving this quadratic we will get sometimes the inequalities. To solve those inequalities, sketch the quadratic and decide the above or below the zero line and write it correctly. Okay. So in this case, it is b square minus 4ac is greater than 0. In this case, we want this part above the line. Okay. So we have to write, suppose this is negative 2 and this is 3. So we have to write the inequality as k is less than minus 2 or k is greater than 3. Okay. So in this case, b square minus 4ac is equal to 0. The quadratic touches the line. So the point of contact, suppose this is 2. So we will be writing k is equal to 2. So this is the third case, b square minus 4ac is less than 0. And we can see the quadratic is not touching the line or does not crossing the line. In this case, we have to assume it crosses the line and the inequality will be this portion. Okay. Suppose again we will take this negative 2 and 3. So k will be in between minus 2 and 3. Okay. Now let us look into some of the questions previously asked in the exams. So first we will see some example for quadratic which has two distinct points, two distinct roots. So let us see one question from the past paper. A curve has equation y is equal to x square plus 2cx plus 4 and a straight line has equation y is equal to 4x plus c, where c is a constant. Find the set of values of c for which the curve and the line intersect at two distinct points. So the keyword is given here, intersects at two distinct points. So we can say b squared minus 4ac is greater than 0. So it intersects. So we can equate both the quadratic and the line equation. So we can write x square plus 2cx plus 4 is equal to 4x plus c and bring everything to the one side. So we'll write x square plus 2cx minus 4x plus 4 minus c is equal to 0. Now we got a quadratic equation. Now we have to find out b square minus 4ac and we know it is greater than 0 in this case. So b square is, let us group this term, x multiplied by 2c minus 4, and this is the coefficient of x, and 4 minus c is the constant. Okay. So now b square is 2c minus 4 square minus 4, a is 1 and c is 4 minus c. This is our b squared minus 4ac. So now let us expand this one. So 4c square minus 16c plus 16 minus 16 plus 4c. Okay, actually this is greater than 0 because two distinct points. So now we got a quadratic equation in C. So we'll simplify this expression. 4c square minus 16c plus 4c minus 12c. 16 minus 16 gets cancelled and this is greater than 0. We will take out c commonly and we can take 4 also. So we'll get c minus 3 greater than 0. Okay. Now if you assign this is equal to 0 to find the value of c, you will be getting c is equal to 0 and 3 is equal to 3. Always draw the quadratic and the line so that you will better understand where the value of c actually lies. So this is 0 and this is 3. Okay. So by looking at the sketch, we know the value of c should be here and in this region. So we can write the inequality as c is less than 0 or c is greater than 3. Okay. So this is the inequality. Now let us see the next question. Find the set of values of the constant k for which the line with the equation y is equal to kx minus 5 intersects the circle at two distinct points. So here the equation of the circle is given and one straight line equation is given. So we will substitute the value of y in the circle equation. So you will get x plus 3 the whole square plus kx minus 5 minus 1 square equal to 6 square, that is 36. Now expand this one, x square plus 6x plus 9 plus k square x square, and this is minus kx minus 6, so minus 12kx plus 36, and bring that 36 to the left hand side, minus 36 equal to 0. You can see the 36 minus 36 gets cancelled. Now combine the x square terms. You will get x square 1 plus k square plus x 6x minus 12k plus 9 equal to 0. Okay. Now we have to find out b squared minus 4ac, and it's given it intersects at two distinct points. So in this case b squared minus 4ac is greater than 0. So b squared minus 4ac is greater than 0. Okay. B square term is 6x minus 12k the whole square minus 4. A is 1 plus k square and is equal to greater than 0. Okay. Now let us expand this one. So you will get, okay, this is 6 only. So you will get 36 plus 144k minus 144k square minus 144k minus 36 minus 36k square is greater than 0. Now simplify this one. So you will get 108k square minus 144k. This 36 gets cancelled. So this is greater than 0. So k multiplied by 108k minus 144. This is greater than 0. So we have to write the inequality. Better draw the sketch first to understand where actually the k value lies. K is 0, 144 divided by 108 on simplification gives 4 over 3. So this will be 4 over 3. Okay. Now this intersects at two distinct points. So we want, and b squared minus 4ac is greater than 0. So we want this part and this part. So we can say k is less than 0 or k is greater than 4 over 3. Okay. So next we'll see the case b squared minus 4ac is equal to 0. So the keywords are two equal roots, are tangent, are touches at a point, are repeated root. Okay. The question is, the point P lies on the line with the equation y is equal to mx plus c, where m and c are positive constant. A curve has the equation y is equal to minus m over x. There is a single point P on the curve such that the straight line is a tangent to the curve at P. Find the coordinate of P, giving the y coordinate in terms of m. So let us draw the curve, and it's given the quadratic touches the curve at the point P. Okay, now we have to find the coordinate of P. So it's given both are intersecting, so we can equate the equations. of the curve as well as the line. So mx plus c is equal to minus m over x. Let us simplify this one by bringing everything to one side. So you will get m x square plus c is equal to negative m x square plus m plus c is equal to 0. Okay, I missed x here. So cx plus m equal to 0. So now we got a quadratic equation. So in this case, b squared minus 4ac is equal to 0. So find out b squared minus 4ac. C square 4, a is m and c is also m. So you will get c squared minus 4m square equal to 0. 4m square can be written as c square minus 2m square equal to 0. So you will get two roots. So c is equal to 2m square, so plus or minus 2m. Okay, and it's given where m and c are positive constants. Okay, it's given in the question m and c are positive constant. So c is equal to 2m. Okay, so we'll substitute this in the first equation. We'll mark this as 1. So you will get m x square plus 2m plus m is equal to 0, 2mx. Okay, we'll take out m commonly. You will get x square plus 2x plus 1 equal to 0. And by looking at this expression, we can say it is x plus 1 the whole square. So x plus 1 square equal to 0. So x equal to, or we can say x plus 1 equal to 0. So x equal to negative 1. Okay. So when x equal to negative 1, we have to find the corresponding y value. So when x equal to minus 1, we'll substitute y is equal to minus m over minus 1, that is m. So the coordinate of p is minus 1 comma m. Okay. Given that the equation 16x square minus 24x plus 10 equal to k, where k is a constant, has exactly one root. Find the value of this root. So in this case, b square minus 4ac is equal to 0. Let us write what is b square minus 4ac here. Further, first we'll rearrange the given equation. 16x square minus 24x plus 10. Bring that k to the left hand side. You will get minus k equal to 0. Okay, now we'll find out b square minus 4ac, that is 24 square minus 4, a is 16 and c is 10 minus k. Okay, here you can write minus 24 square also. Anyway, you are going to get positive value for b. This is equal to 0. 24 square is 576 minus 640 plus 64k is equal to 0. And 576 minus 640 is 64 plus 64k equal to 0. So 64k is equal to 1. 64k equal to 64, or we can write k is equal to 1. So it's given find the value of this root. You have to find a root. Not only finding the value of k, you have to find the root. So substitute k value as 1 in the given equation. So you'll get 16x square minus 24x plus 10 is equal to 1. This can be plus 9 equal to 0. Okay. Now find out b squared minus 4ac to find the root of that. And we know it is equal to 0. So we can directly find the root minus b divided by 2e. Okay, that is the formula to calculate the root. See, it's going to have only one root, and b squared minus 4ac term is 0. So we are directly going for this. Okay. So x equal to 24 divided by 2 multiplied by 16. So which is nothing but 3 over 4. So x equal to 3 over 4 is the root. The next question is, it's mentioned no real root or do not intersect. So this is the case b squared minus 4ac is less than 0. Okay. So in this question, see, find the set of values of k for which the equation 8x squared plus kx plus 2 equal to 0 has no real roots. So it's mentioned there is no real roots. Okay. So in this case, b squared minus 4ac is less than 0. Okay, let us find out what is b squared minus 4ac value here. K squared minus 4, 8 multiplied by 2. And this is less than 0. So you will get k squared minus 64 is less than 0. Now to find the k value, let us assume k squared minus 64 equal to 0. So you will get k squared equal to 64 and k is equal to plus or minus 8. Okay. Now to write the inequality, first let us sketch the graph. So now this is negative 8 and this is positive 8, and has no real mean it should not touch. So if it should not touch mean if k is in this region it will not touch. Okay. So we will write the inequality as minus 8 less than k less than 8. So 8 k lies between negative 8 to positive 8. Okay. The next question is, a curve has the equation y is equal to kx squared plus 2x minus k, and a line has the equation y equal to kx minus 2 where k is a constant. Find the set of values of k for which the curve and line do not intersect. So do not intersect. B squared minus 4ac is less than 0. First let us equate both the equation. Kx squared plus 2x minus k equal to kx minus 2. So kx square, bring that kx and minus 2 also to the left hand side. So you will get 2 minus k plus 2 minus k equal to 0. Okay. Now let us find the b squared minus 4ac. We know it is less than 0. So 2 minus k square minus 4a and c value is 2 minus k. Okay, this is less than 0. 4 plus k square minus 4k minus 8k plus 4k square. Now simplify this one, you will get 5k square minus 12k plus 4. This is less than 0. And to find the value of k, we will assume this is equal to 0. Okay. So find the value of k. We will use the quadratic formula. 12 plus or minus square root of minus 12 square plus, okay, all are negative only, positive only. So minus 4, 5 multiplied by 4 divided by 2 multiplied by 5, and this is equal to 12 plus or minus 12 square is 144 minus 6 multiplied by 5 multiplied by 4. So 80. So it gives 64. So we'll write 8. 10. So k is equal to 12 plus 8, that is 20 divided by 10 is 2. Or k is equal to 12 minus 8, 4 over 10. Can be written as 2 over 5. Okay. So these are the k values, and we have to write the inequality. First, let us sketch the graph, sketch the quadratic to know where k lies. So this is 2 over 5 and this is 2. Okay. And b square minus 4ac is less than 0. So k should be in this region. So we can write the inequality as 2 over 5 less than k less than 2. Okay. So it's given, find the set of values of k. Okay. Let us see one more example. A line has equation y is equal to 3x minus 2k, and a curve has the equation y is equal to x square minus kx plus 2, where k is a constant. Show that the line and the curve meet for all the value of k. Okay. So we have to assume in this case b squared minus 4ac is greater than or equal to 0. Okay. First let us equate both the equation. So x square minus kx plus 2 is equal to 3x minus 2k. Bring every term, all the term to the left hand side. So x square minus k minus 3 and 2k plus 2 equal to 0. Find out b square minus 4ac minus k minus 3 the whole square minus 4 multiplied by 1 multiplied by 2k plus 2. Okay. So expand this one, k square plus 9 plus 6k minus 8k minus 8. So k square minus 2k plus 1. Okay. Now we are getting a quadratic equation in k. To find the value of k, let us assume this is equal to 0. And we know this is k minus 1 the whole square. And we had to show that the curve and the line meet for all the values of k. Okay. Suppose now take the k value as 1. So you will get this is equal to 0. Okay. So in that case, it is a tangent. It touches the curve. And if k takes any other value other than 1, like negative 1 or positive 2 or whatever value, if it is 0, for all the value of k, you will get some positive value because it's whole thing square. Okay. And when k is equal to 1, that case it will become a tangent. So k minus 1 the whole square is greater than or equal to 0 for all the values of k. So I hope now you're clear with the discriminant concept.